So for this video, we're going to talk about 5A, the fundamentals of statistics. I believe we'll also be doing 5C from this section. And there's just a lot of information in this section. So this will be not a lot of calculation like in the previous chapter 4 on working with exponents and trying to find interest and trying to find, monthly payments and stuff like that. So this will be a little bit more on definitions and identifying what something is, and then a little bit on graphs. Okay. So the fundamentals of statistics. So first thing is we want to talk about the two definitions of statistics. Statistics is the science of collecting, organizing, and interpreting data, but statistics can also be referred to as data that describes or summarizes something. In general, statistics, when you're using statistics, it describes the sample. When you're using a population, it's called a parameter. So normally when you're talking about statistics, it's describing a sample. And then obviously you can use it as the science of collecting data and interpreting data, okay? A few definitions. The population is a statistical study. The population in a statistical study is the complete set of people or things being studied, okay? So there's a little bit of a gray area sometimes on how to differentiate between population and samples. So for our class especially, we'll try to make it obvious. It says the sample is the subset of the population from which the raw data are actually obtained. So you could say an example, you could say, all the babies born in the United States. Okay. So now technically, when they say all the babies born in the United States, that's the population. They want to know the population of all the babies born. Then what they're going to do probably is in a study, they're going to take a part of or a sample of the babies born, okay, from the population. However, you could think about it differently. You could say, well, the United States is not the entire world. So technically the United States babies being born is a subset of the world's babies being born. You see how it could be either? So that's why we'll try to make it pretty obvious. Whenever they use the words like all or the entirety or the entire, they're normally wanting you to think of it as a population. Okay, so population parameters are specific numbers describing characteristics of the population. Just kind of the way that I remember it is parameter and population. Parameter and population. You know what? I wrote that really small. Let me fix this a little bit. For some reason. Yeah, let me write it like this. So parameter and population. And I just think P and P, they go with each other. Parameter starts with a P, population starts with a P. Now look at this, sample statistic. Statistic and sample. They go together and they both start with S. So if you're not sure when to use the population or when to use the parameter and when to use a statistic, it depends on what you're talking about. If you're talking about the population, then you're going to use, wrong button. Oh man, I'm just hitting everything wrong today. You're going to use the parameter. If you're talking about a sample, you're going to call what you're dealing with a statistic. Okay. So population parameter and sample statistics. Sample statistics are numbers describing the characteristic of the sample found by consolidating or summarizing the raw data collected from the sample. So basically, parameters and statistics are ways to describe either the population or the statistic, and maybe describes the wrong word, but they use that too. It's basically talking to you or explaining to you what you're looking at or measuring in this particular problem. Okay. So describe the population, sample, population parameters, and sample statistics. Okay, so let's look at this. All right. So it says agricultural inspectors for Jefferson County measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms in the country. Okay, so let's talk about the population. Okay, so we know the population is agricultural inspectors from Jefferson County measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms in the county. So the population is all ears of corn grown in county. So that's what they want to talk about. They want to talk about everything that's grown in the county. Okay. All the ears of corn, I should say. All right. So then it says the sample. Oops, I have it right here. I'm sorry. So they do this by studying the sample that consists of the 25 ears from each farm. So we have the population, all the ears of corn grown in the county, and then the sample is 25 of ears of corn from each farm. Okay. So if there's 104 farms, you could figure out how many ears of corn they're doing. You do 104 times 25. The population parameter are the average level of residue from the 3 pesticides on all corn grown in the county. So here it says from residue from 3 common pesticides, okay? Now, the sample statistic describes the average level of residue that actually measured on the corn in the sample, okay? So population parameters are the average levels of residue from 3 pesticides on all corn, right? So remember, if you're talking about a parameter, you're talking about the entire population, okay? So when they say on all corn, that's kind of a giveaway. Then it says if you want to talk about the sample statistic, you're going to describe the average levels of residue that are actually measured on the corn in the sample, which would be the 25 ears of corn from 104 farms. That would be the sample, okay? So basic steps in statistical study. State the goal of your study, choose a representative sample from the population, collect raw data from the sample, and summarize these data by finding statistic of interest. By finding sample statistics of interest, use the sample statistic to infer the population parameter and draw conclusions. So that's why in the beginning up here, it talked about statistics as a science. The difference between, like, if you think of like lab experiment science and statistics is basically using just collected data to make inferences, and then based on their data, see how strongly they feel about their conclusion. Do they feel that they have enough evidence to support their conclusion, or does more data need to be gathered, or is there something happening? So this is basically, they're kind of outlining to you how you would go about producing your own statistical study. So elements of a statistical study: you have to identify your goals, okay? You have to basically have a population that you're going to draw from, but then the moment you draw from that population, you now have a sample, and then collect raw data and summarize, okay? So remember, what describes the sample is called the sample statistic, okay? Now, make inferences about, so here's the kind of the goal overall, okay? So the goal overall is, you see how these arrows kind of go like this? Okay, you see how it kind of goes like that? I want to talk to you about that real quick. Okay, so what they're saying is you identify the goals that you want to talk about in the population, but obviously, let's say you're trying to talk about all Americans, right? You want to talk about all Americans. Well, there's no way that there's enough funding or enough time to interview and gather data on 350 million people exactly. So, or however many people are in the United States. So what they want you to do is take a large sample. So if you were talking about the United States, you would take a large sample from the United States, obviously not everyone. And there would be, if you took statistic, there would be a number that's kind of an agreed upon value that you're allowed to take from 350 million. But again, it's kind of a gray area in that also. But the main idea is that you're going to gather data from this sample, and then it's going to be randomly chosen data. That's one of the most important things about gathering data, is it must be randomly chosen, and chosen in such a way that you are not sampling or kind of demonstrating bias in the way you're sampling, okay, or in your study. So from that sample, okay, that we drew from the population, we're going to come up with a statistic. We're going to analyze that data, and we're going to have a statistic. And that statistic is going to tell us something, right? So this statistic is going to tell us something. And what the attempt is that statistic should tell us something about the population, right? So it all leads back to the population. So one of the main reasons that we study statistics and we use statistics is so we can make inferences about the population based on a sample. Instead of having to do the entire population, we can do a sample. And then if you took me for statistics, we would say, oh, we are 95% confident that the true population proportion lies between this and this. So that's how you use statistics, okay? And again, you could be wrong. A lot of the times in statistics, it has its built-in error where it tells you, well, I'm only 95% sure I'm right, or I'm only 99% sure I'm right. So that's something in a statistics class, not in ours. We're just covering a little bit of the basics of statistics, okay? But again, the main idea, big idea is to use a sample to make inferences about the population. That's kind of the big idea behind it, is you want to be able to talk about the population, but it's too big, so you use a sample to talk about it. And then there's a lot of math that's behind it. We're not going to go so much into the math part. We're going to go more into the definitions and kind of the terminology and the ideas behind it, okay? So it says each month, the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest in the U.S. unemployment is the U.S. unemployment rate, defined as the percentage of people who are unemployed among all those who are either employed or actively seeking employment. Describe how the 5 basic steps of statistical study apply to this research. Okay. So instead of writing all these out and, having you read my writing, I felt like this time I was going to leave this slide up because it kind of summarizes it just as good as I would have. So step 1. So let's go back up here to our step 1. State the goal of your study. Okay, so the goal of my study, the goal of the research is to learn about employment or unemployment within the population of all Americans who are either employed or actively seeking employment. Okay. Step 2, let's see what they say about step 2. Choose a representative sample from the population. Okay, so we're going to come over here and we're going to say the Labor Department chooses a sample consisting of people employed or seeking employment in 60,000 households. Now, that's obviously not the entire United States, but that's a good sample. Okay, 60,000 is a lot. Now we got to go to step 3. Step 3 says collect raw data from the sample and summarize these data by finding sample statistics of interest. Okay, so let's see what our interest is. Now think about the problem. The Labor Department asks questions of the people in the sample, and their responses constitute the raw data for the research. The department then consolidates these data values into a sample statistic, such as the percentage of people in the sample who are unemployed. So they might ask you, so here it says the Labor Department chooses a sample consisting of people employed or seeking employment. Okay. But the only thing is they don't tell us what questions they're asking them. But we know it has to do with something with if they're employed or if they're unemployed or if they're seeking work. There's a lot of data they could gather. And then they try to identify something that they want to talk about it. So it says, based on the sample statistic, the Labor Department makes estimates of the corresponding population parameters, such as the unemployment rate of for the entire United States. So what they're saying is from these 60,000 households that they discussed, they then try to use that to talk about the unemployment percentage in the entire United States. Normally, a population parameter, I shouldn't say a population parameter, a lot of times we use something called a population proportion, which is a percentage of the population normally. And we try to estimate that with whether it's with confidence intervals or hypothesis testing. We'll try to say if it's bigger or smaller than a certain value or not equal to a certain value. But basically, in step 4, this is where we're trying to, so we look up here. In step 4, this is where we're trying to use the sample statistic to infer about the population, okay? So the data that we're gathering, we hope it leads us to something, okay? And then it says the Labor Department draws conclusions based on the population parameter and other information. For example, it might use the current and past unemployment rates to draw conclusions about whether jobs have been created or lost. So this happens all the time, and people, try to mislead you with statistics. Instead of telling you the percentages, they'll tell you about. So if you compare like how many people were unemployed, 75 years ago versus how many people were unemployed currently, You know, it would be a lot more now. Instead of telling you in proportion to the United States as a whole, instead of telling you the percentage, somebody might just tell you a quantity. And the quantity would be misleading because there's obviously more people in the United States right now. So then there'll also be more people unemployed. So the percentage is something that's much more important. Okay. I guess percentage could also be misleading if it was done in the wrong context as well. So it could go either way. Definition, representative of sample. So a representative sample is a sample in which the relevant characteristics of the sample members are generally the same as those of the population. So yeah, when you're taking a sample, you normally want the sample to have similar representation in the population. Okay. So it says, here's some common sampling methods to kind of make sure this happens. Simple random sampling. Okay, we choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. Okay, systematic, and again, the randomness is what's very important to statistics. So a simple random sample is very important, and in general, all statistics, you want either a simple random sample or a random sample. Okay. Systematic sampling. We use a simple system to choose the samples, such as selecting every 10th or every 50th member of a population. Or if you were trying to do in a neighborhood, you could do every 17th house. But the randomness would come from where the starting point is. Okay. So convenience sampling. We choose a sample that is convenient to select, such as people who happen to be in the same classroom. So if I wanted to do a study on statistics, students and their grades, and then I just waited outside my class and just talked to each of you, you know, that's kind of, you know, convenient. That's like, well, it's just my students right outside my classroom. So that makes it a little bit weird that I'm doing it that way. So normally you want to provide a random sample and not have it be something that you're only doing because it's easy for you to do. Okay. Another one is stratified sampling. This one's kind of important to make sure that you get a lot of, um, how do I say this? A lot of, the data is well representative of the population. So we use this method when we are concerned about differences among subgroups or strata within a population. We first identify the subgroups and then draw a simple random sample within each subgroup. The total sample consists of all the samples from the individual subgroups. So this one's a little bit harder. I want to come over and do an example. Let me just double check something real quick. Yeah. So I want to do one of this one real quick. I mean, there's more in there, but I want to talk to you guys about one. So suppose you are studying the cost of living. So we're going to study, suppose, I'm not going to write out full sentences. Suppose, just for time constraints, we are studying, suppose we are studying the cost of living in San Diego. Okay. We sample, or let's say this, we want to sample 1,000 households. Okay. Now, here's the problem. Okay. Let's divide San Diego into some categories. So let's think about San Diego County. And let's see what we have here. So we could do, we have the South Bay. Okay. Then we have the East County. And this is my strata. This is how I've chose to cut up San Diego County. We're going to do Central San Diego. Let's go over here and let's do Coastal. And then let's go right here. Let's do North County. Okay, so I have these. Now these are my strata. Okay, so I've divided San Diego County into my strata. Okay, so I created 5 of them. Now the thing about stratified sampling is I'm not going to take from each one of, I'm not going to take everybody from each one of these. That would be too hard. Okay. So what I'm going to do instead is I'm going to take 200 people from South Bay. I'm going to take 200 people or 200 households from East County, 200 from Central, 200 from Coastal, and 200 households. I'll put HH for households. So what this does is, now imagine if you were a researcher and you were trying to gather data on San Diego County and you wanted it to represent San Diego County. But let's say you just did a simple random sample. Is it possible that a large majority, when let's say you're drawing, addresses out of a hat, or, zip or phone numbers or whatever out of a hat, and it's just completely random. So you're doing your job, you're doing it random. Is it possible that you could get a vast majority of your information from North County and coastal San Diego? And then based on that, so let's say, you got a whole bunch from North County and a whole bunch from Costa, and very little representation from Central, East County, and South Bay. Okay. And you did your job right, supposedly, right? You did a random sample, so everything should work. The only problem is that it was just bad luck for your study that you happen to get everybody from North County and coastal for your 1,000 people. So what the stratified sampling does is it prevents that from happening, right? Because now we're taking 200 from every single one of my strata. That means all of them are going to have representatives. And then I'm going to randomly choose 200 from here. I'm going to randomly choose 200 from here. I'm going to randomly choose 200, 200, and 200. So I'm still going to get my 1,000, okay? And now I have a good sample from every single area of San Diego County. And that way, the data I now gather, I feel much more confident that it is a good representation of San Diego County, as opposed to getting unlucky and only gathering it from North County and coastal, or only gathering it from South Bay and East County. Each area has a different input. And if I don't use stratified, there's a chance that I would not get a good or a valuable set of data. Okay. So that's kind of what stratified does, is it builds things or cuts things into stratas or separates them into stratas. And then you take a sample from each of the strata, but you take a sample from all the stratas. Okay. So that's kind of the big deal about stratified sampling. So simple random sample, common sampling technique, simple random sampling. Every sample of the same size has an equal chance of being selected. Computers are often used to generate random telephone numbers, and they all have the same probability of being selected. If there's 100,000, it's 1 out of 100,000 for each one. Okay, and then they're randomly chosen. Systematic sampling. I can do one for that one that's a little bit better than their example. Okay, so let's say in systematic sampling, suppose okay, and this was stratified. Okay, oops. That's not any better. Sorry about that, you guys. Okay, so we have systematic sampling, and suppose we want to sample 8 houses from a street of 120. We want to sample 8 houses from a street of 120. Okay, houses. So what I'm going to do is I'm going to do 120 divided by 8, and I'm going to get 15. So what I'm going to do now is I will choose every 15th house once a random starting point is chosen. Okay, so I have a random starting point. So that way I still can say that it's random instead of picking every 15th house and starting at one, then I kind of know the outcome. But if I randomly choose where I'm going to start, then every 15th house, it is very systematic. I'm going to do it in a certain way, right? However, the starting point is chosen, or it's chosen randomly. So that's what helps. So if I wanted, if a random, let's say if the random starting point is the 14th house, okay, then choose the rest. What would the next be? So then we're going to have the 14th, then we're going to add 15 and we're going to get the 29th house. Then we're going to add 15th and get the 44th house. We're going to add 15 and get the 59th house, 74th house, 89th house, 104th house, and 119th house. So these are all the houses I'm now going to choose because I started at the 14th. If I started at the 13th, I'd get a different set. So hopefully you guys can see that that's how systematic sampling will happen. Convenient sampling, use results that are readily available, just talking to people like outside your door or in your neighborhood. I kind of went over stratified already. So it says identify the sampling method used in each of the following cases and comment on whether the sample is likely to be representative of the population. Okay, so let's see here. Let me just kind of. Okay, so this first one, it says you are conducting a survey of students in a dormitory. You choose your sample by knocking on the door of every 10th room. So I think it's obvious every 10th room is similar to the house problem of every 15th house. So this is systematic. So this is systematic sampling. Okay, and the sample may be representative as long as students were randomly assigned to rooms. Okay, so you can't try to pick certain rooms that what students are in which ones. Like if you say every 12th room has this, and then I'm going to do by every 12th room or every 10th room or whatever. So you got to be careful with that. But yeah, that definitely sounds like systematic sampling to me. Let's see, to survey opinions on a proposed new water line, a research firm randomly draws the addresses of 150 homeowners from a public list of all homeowners. So that sounds like a simple random sample. Okay. Let me just make sure we're doing okay on this. Yeah, okay. And I would say this has a pretty good chance of being representative of the population. And likewise with this one, this should be a pretty good sampling as well. So let's look at part C. Sorry, guys, I lost my notes for a second. Agricultural inspectors for Jefferson County checked the levels of residue from 3 common pesticides on 25 ears of corn, each of the 104 corn producing farms in the county. Okay, so each farm may have a different pesticide to use. Okay. So the inspectors could consider corn from each farm as a subgroup or strata. So I want to use 25 of each. So what they did is they split it up into 104 corn producing farms, and they're taking, so imagine you had 104 farms, right? That's kind of like our San Diego County. Okay. And then we're going to split off from each one of these, and we're going to take 25 ears of corn, 25 ears of corn, 25 ears of corn, 25 ears of corn, so on and so on and so on. Okay. So this is stratified. Okay. So I feel like this is definitely a stratified sampling. And I would say that this would be also a good representative because they're taking from all the farms. Now, they're not taking every ear of corn from the farm. They're only taking a sample from each, but that's exactly what stratified sampling does. And I think this would be a good representative of the population, okay? Anthropologists determined the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites in southern Europe, okay? So let's see what we got on this. Now, this sounds like anthropologists determined the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites in southern Europe. Well, I mean, this is convenient sampling, but sometimes it's not, sometimes it's not. In this case, they kind of had to, because if you're trying to study the skulls found at 3 sites in southern Europe, maybe that's all they had. That's all they have to work with. So those 3 southern sites. So it is convenient sampling. I could see this being okay and a representative of the population for Europe, and only by studying southern Europe because that's what's close, or maybe that's all they have. But I don't really know in a study like this if they have options other than to do convenient sampling. Okay, normally convenient sampling is considered bad. Okay, but in this case, I don't know if they'd have a choice in doing it. So these other 3, and when I teach my statistics class, these other 3 are good sampling techniques. But convenient sampling is normally frowned upon. But in this case, I don't know if they would have a choice. So this is convenient sampling. Definition: bias. So a statistical study suffers from bias if its design or conduct tends to favor certain results. So sometimes that is a problem with convenient sampling, is it can lead to bias in your study. Okay, so you got to be careful of that. Types of statistical studies. So we don't want bias, by the way. Bias is bad, right? We don't want that in our study. We want it to be scientific and let the facts speak for themselves and let the data speak for themselves. So bias is not something we want in our studies. So this is a negative thing that we're trying to keep from happening. So types of, and that's, by the way, that's why you use stratified sampling. That's why you use simple random sampling. That's why you use systematic sampling. There's also cluster sampling and other types of sampling that are used to try to prevent bias and things like that from coming into play. In an observational study, researchers observe or measure characteristics of the sample members, but do not attempt to influence or modify these characteristics. So this is observational, where they do not actually try to change anything. Okay. In an experiment, especially like, for example, in the medical field, they will administer medication and then try to see the results. So researchers apply a treatment to some or all of the sample members and then observe the effects of the treatment. Okay. So this video is going a little bit longer. I'm going to kind of speed up a little bit. So treatment and control groups. The treatment group is an experiment. Um, the treatment group in an experiment is the group or of sample members who receive the treatment being tested. So think again of medical. If they're giving you a specific drug to, counteract, whatever it's COVID-19, they're doing this right now with COVID-19 and everything like that. You have control groups in the experiment is a group of sample members who do not receive. So you have to have people that do not receive the treatment so you can compare the results to the people that do. Okay. So you have a treatment group who receive the actual treatment, the medication, whatever it may be. It doesn't always have to be medication. It could be the treatment for a class, could be people that attended a review session versus people that did not. So the control group in that case would be the people that did not attend the review session, and the people that did attend the review session would be the treatment group. Okay. It is important for the treatment and control groups to be selected randomly and be alike in all respects except for the treatment. That way you can kind of tell. That's kind of the problem right now with a lot of the COVID-19 stuff that's going on. Some of the data that people are giving it's not related to the other data, so that you kind of can't compare them. It's like apples and oranges. But anyway, you just got to be careful with that. A placebo lacks the active ingredients for the treatment. So basically, what a placebo is it's a fake treatment. It doesn't actually do anything, but they still pretend to give it to you. Kind of like if you were getting a certain drug for, let's say, for cancer, they would give everybody a drug, but one of them would be the actual medication and the other one would be like a saltwater tablet or something like that. That's what's called a placebo, where it doesn't actually do anything. Um, because they want to see if the treatment is actually affecting it or is it your mind that's doing it. Okay. The placebo effect refers to the situation in which patients improve simply because they believe they are receiving a usual treatment. So, kind of like that whole positive vibes thing, you think because you're getting a treatment, you're going to get better. So then your mind kind of tells you you're feeling better, even though you were just getting a saltwater tablet or something, nothing real. Okay. Blinding is something that's used often in statistical terminology, or it's a statistical terminology, the practice of keeping people in the dark about who is getting the treatment and who is in the control group. That's called blinding. Sometimes there's something called double blinding, where the researcher, as well as the groups, the control group or the treatment group, they're double blinded. Nobody knows who's actually getting the treatment. So they might do that for, like, a certain medication that they're pretty sure is going to help people, let's say with cancer. They don't want the researcher to know that the people that are giving the saltwater tablet are, may not make it or whatever. So they have to do a double blinding in that case. So the researcher doesn't, feel sympathy and change the outcomes and things like that, or also for humane, so they don't, like, if they like somebody, they don't know if they're giving them the good of value, the good treatment or not. So sometimes that's called double blinding, but in general, blinding means that the people receiving the treatment don't know what they're getting, and double blinding is when the people receiving it as well as the person administering it do not know. Okay. An experiment is a single blind if the participants do not know whether they are members of the treatment group or the control group. So I just talked about that. A double blind is if neither participants nor experimenters, people administering the treatment, know. Okay, so I talked about that already. So it says for each of the experiments, describe, identify the problems, and explain. So I think we're getting close to the end. Let me see if this is it. Oh, there's still a lot. Okay. So some of this I'm not going to go too deep into. Okay, so let's talk about a chiropractor performs an adjustment on 25 patients with back pain. Afterward, 18 of the patients say they feel better. He concludes that the adjustments are an effective treatment. Okay, so let's talk about that real quick. All right, so let me go through my notes real quick. So what does this study lack? So he had an adjustment on 25 patients with back pain, and 18 of the patients say they feel better. So now here's the thing. What did he not, or he or she, forget to have? There's no control group. So you need people that did not receive treatment. Now, the problem is this isn't like giving a medication. People would obviously know that they're receiving back adjustments or something like that. Yeah, so this is definitely no control group. I would say that's the main problem. Um, you know, it's kind of hard when you don't, and not now, again, not always is there a way to have a control group, but this would be a case where not having a control group, you don't know if maybe people just got better without chiropractic or without the help of a chiropractor. Maybe the pain just went away on its own. So that's something that you want to definitely think about for that problem. And then for this one, it says a new drug for a type of attention deficit disorder is supposed to make the affected children less disruptive. Randomly selected children suffering from this disorder are divided into treatments and control groups. Sorry, guys, my cat is hungry, I guess. Those in the control group receive a placebo that looks just like the real drug. The experiment is a single blind. The experimenters interview the children one by one or one-on-one to decide whether they became more polite. Okay, so I'm a little worried about this one. So let's see here. All right, so what's wrong with this? All right. Because the experimenters know which children receive the drug, it might influence what they think. So experimenters know which children received the drug. So that's a problem. The solution might have been better to do a double blind. It's kind of like that thing. I don't know if it's true, but I heard that if, parents all often think that when they give their kids sugar, they go crazy and get all wild. But, maybe kids are just wild in general and we perceive it because of the sugar. I think that I remember reading something about that it's just our perception because we gave them sugar. That's why they're acting like that. When in reality, it could just be the kids are wild in general. Okay. So this experiment should have been a double blind because the researchers, and again, it says they interview the children one-on-one and decide whether they become more polite. Well, they might now read into things because now they know which kids received the treatment and which kids did not. So they needed to do this as a double blind, I think would have helped. They needed for them to not know. So a retrospective study is an observational study that uses data from the past, such as official records or past interviews, in which case the sample naturally divides into a group of cases who engaged in behavior under study and group of controls who did not. I'm not going to go too much into this, but retrospective study basically is saying that the data is already there and you're going to go back and look at it. You weren't the actual person. They might do this like, for water purification, they might, or, levels of rainfall, they might look at the data over the last 20 years and see what, is going on and gather all that data. So that's a case of a retrospective study. So for each of the following questions, what type of statistical study is most likely to lead to an answer? Why? Okay, so let's look at this. So it says, what is the average income of stockbrokers? So you're not going to give stockbrokers a treatment or anything like this. So this would not be an experimental study. This would be an observational study. Okay. We only need to survey the stockbrokers. We don't need to administer a treatment. Okay. Do seatbelts save lives? So it's kind of hard to do an experiment with this one because you'd basically be saying, hey, some people get in a car accident and wear your seatbelt, and then some people get in a car accident and don't wear your seatbelt. So we kind of can't do that. So we would have to do a retrospective study. So we would have to do retrospective. Do you guys see? I hope you see why you couldn't do an experiment, because that's not good, because you'd basically be asking people to risk their lives just so you could gather some data. But if you did a retrospective study, then that means you could take data from past car accidents that have already occurred and see the fatality rate of people who wore a seatbelt versus those who did not. Okay, so definitely retrospective would be the way to go on that one. Can lifting weights improve runners' times in a 10-kilometer race? To me, this is a no doubter. This has to be, determine weightlifting can improve 10K times. This is definitely an experiment. Oh, I forgot how to spell. So we need an experimental study to determine this, or just an experiment actually to determine this, because we want to have people that lift weights, and then we want to have people that don't lift weights. So the treatment would be lifting weights, and then the people that don't, and see if that improves the time. So we would need a treatment group and a control group. Okay. So I think that's okay. That's not too bad. Can herbal remedies reduce the severity of colds? Huh. Also a strange one. Oops. I would say we need to do a double blind experiment in this one. So this would be double blind. And again, because the kind of the idea behind herbal remedies is, it's not actual like medical science. So maybe people that believe one way or the other in the herbal remedy would kind of like with the kid one, where if you give a kid sugar, is it really the sugar that's making the kid act that way, or is it your belief that the sugar is what's doing it? So I would say a double blind would be necessary, a double blind experiment. And measure the treatment group for the people that receive this herbal remedy, and then people that do not receive the herbal remedy. But you give them a fake one, so you give them a placebo, something that doesn't do anything, but they might think it does or whatever. So I think a double blind would really help, where the researcher doesn't know, as well as the people getting the herbal remedy don't know what they're getting, just in case there's any bias or anything like that towards these types of remedies. Last little thing, I think this is our last two slides. Yeah, okay, good. And these are pretty straightforward. Margin of error is used to describe the confidence interval that likely to contain the true population parameter. So all you do is you take the sample statistic, so whatever value you're talking about, like if you're saying 22 ears of corn seem to be infected or whatever with this residue, you subtract the margin of error and you add the margin of error, okay, from the sample statistic. Okay, so it's like you do a plus minus. All right, so it says an election Eve poll finds that 52% of surveyed voters plan to vote for Smith, and she needs a majority more than 50 to win without a runoff. The margin of error in the poll is 3%, 3 percentage points. So an election poll, this is a sample, right? They took a sample and it found that 52% of surveyed voters plan to vote. So we're going to build this little confidence interval. And what we're going to do is we're going to say 52% minus 3%, because that's my margin of error. Right here it says the margin of error. And then I'm going to do 52% plus the 3%. So that will give me 49% to 55%. Okay, and she needs a majority, more than 50%, to win without a runoff. Does this guarantee that she will win without a runoff, or is there a chance that she may not win without a runoff? And the answer would be it does not guarantee it, because notice there is a chance that you get 49% in our confidence interval. So what a confidence interval basically says is, I don't know the true answer of the population. I don't know exactly what the population is going to, how it's going to behave, or how to describe the exact values. But what I can say is that based on the margin of error, the answer is somewhere between 49% and 55%. Okay, that's what a confidence interval says. Okay, so confidence, and in statistics, you would say, if this was a 95% confidence interval, you would say, I am 95% confident that the people that plan to vote for Smith will be between 49% and 55%. Well, that's good, but it kind of also does have bad, because that means there is a chance that she won't get, or he, is it a he or she? It doesn't say. Oh, she. So there's a chance that she will not get the required votes to win, right? Because she could only get 49% of the vote, and it says she needs 50. Okay, so I think there's one or two confidence interval questions, but basically confidence interval is you're building a window, and you're telling them that the answer is somewhere within this window. Okay, and you have to decide from problem to problem if you get the results that you're looking for. That's going to do it for this video, guys. It's a rather long one. Thanks for watching, and I will see you in class.